as we work more and more with programming, we're going to want to start to package things up more and more. Now, as like someone who's probably done math or gone through high school math or physics or any sort of science, once you do a certain type of problem, you a lot of times like you come up with what's we would call an algorithm in your head. Like you know how to do it, you know the approach to do it. One of the annoying things with taking exams, I think sometimes, is you have to remember that algorithm and then reapply it again and again and again. In programming, what we're trying to do is you come up with that algorithm and then you save it. You actually try to save it in your code so then you can deploy it again and again and again. And I mean, what is an algorithm? It's really just a series of logical steps and operations that you have figured out. And programming at the end of the day is really just doing layers and layers of that, coming up with a logical flow of ideas of how to take in information and process it, and then doing stuff with it and putting it into words. And one of the first steps, one of the main things we want to do when we're coming up with these reusable pieces is use what are known as functions in Python. Now, in all other languages. Now, we can, of course, go and here if we wanted to save a file, let's say, again, let's just call it, I don't know, let's call it file2. Okay, and let's say we wanted to have a file that was, I don't know, calculated the square, the cube, and the fourth power of some variable. And let's say that variable is x. Okay, and we'll just set it to be 5 for right now. And then we want to print x squared, print x to the cube, and then print x to the fourth, right? And if we save that and run it, we'll get those three things. Okay, and if maybe we wanted to go back, now we have this nice little piece of code, we can go back and say, well, let's figure out what it is whenever x is 7, and then run it. And then it does it for us. Or if x is 78, and then we run it. And those things all work out. And this is, nice. This is actually a good way to test some things out, right? And you're saving your thought process right here. I'm not going in and repeatedly having to go, oh, okay, well, let's, x, what's 78 squared and then 78 cubed, right? We're being smart. We're reusing stuff we've already written. And the next step, instead of just having a file which runs once, is within that file we can actually start to package our thoughts, our algorithms, into things called functions, okay? And in Python, a function is created like the following. So we go and we do def, which stands for definition, or define, and then we're going to call the function something. Let's call it power calculator, power calc, all right? And we're going to say it takes in an argument. Let's call it x. Okay, and then what's it going to do? It's going to print three things. It's going to print x squared, print x cubed, and then print x to the fourth, okay? We can save that then. And then if we were to just run it, okay, that's great, nothing happened, but over here we could do power calc and then do 5, for example, and it works, okay? Or power calc, I don't know, 123. Okay, and it worked, right? If we didn't want to, for testing purposes, we could have also actually just down at the bottom of the file gone power calc 128, right? And then power calc 47 or something, I don't know, and then run it. And we can see actually both those things worked. And we could have even labeled it a bit nicer so we would understand what's happening. What is it? 128. Let's just add a colon right here so life's nice. Okay, we run it. Look, and we can go and look at the readout, and it's like, this is good, this is good. These things are actually starting to make sense. Okay? Now, whenever you're writing functions in Python, you can have them, do stuff internally or print things. You can also have functions return things. And this is very similar to the idea of, we maybe have a function, let's say, f of x, right? And we're going to say it's equal to, I don't know, 5x squared plus 3x plus 11. Now, we've seen these sort of things in math a whole bunch of times in our lives, right? And we know we go and you give us an x and then we plug it into the x and right, and we get the value out. We can do the same exact thing when we're in Python, actually. So, for example, let's actually define a function now, def f, and it's going to take in an input x, all right? And it's going to return that thing we were just talking about. So let's actually code up a Pythonic version of this algebraic function. So 5 times x squared plus 3 times x plus 11. Okay? And then down below that, let's actually do a couple runs on that. So let's print that function whenever the input is 6. Okay? And let's print that function when the input is, I don't know, 39. And let's see what that does. So when we run it, and that, let's go back and actually add in just a little header so we know what we're seeing. And if I run that, okay, we can see, oh, testing function f. All right, and it actually worked down here. All right, which is very nice. Now, functions in Python, whenever they return something, you need to either capture it with a variable or have it be the input to another function. So that's the main difference between a return and a print. So a function like PowerCalc right here, which has nothing but prints in it, you can't actually do something like b equals PowerCalc of, I don't know, 5, right? Now, it didn't crash, and why didn't it crash? Well, if we were to go and see, well, what is b? B is actually none. It's nothing. So we can actually check that by just doing that. We can see b is nothing, because if we look at PowerCalc, it doesn't return anything. But f right here actually does return something. So if we go back to our code and we were to say b equals f of 14, all right, so b's there. If we would actually type b, we actually get something, right? And if we do type of b, we see it's an int, all right, which is really cool. And so that's something to just keep in mind when you're writing functions. And functions also, they don't need to have just one input. We could have another function, let's call it def_g, and let's have it take in 2 arguments, x and y, right? And have it return x plus 67 times y, okay? And if we were to, and let's, again, let's put a little bit of a header, so testing function g, and then if we were to just print g of 1, 2, and save it and run, we can see right here we have tested function g and the output is 135, and then it's accessible for us in the terminal, so we could go g of 98 and 0.12, right? And what would that be? This thing. So that actually should make sense. And again, functions, they can do both prints and returns, right? We could modify g of x to do, say, I don't know, calculating. And whenever we were to run this, whenever it's testing function g, that print statement of calculating is coming from running function g right here, and then we print the value that's returned. If we didn't print it, we just called it, let's say, we will not get this final 135 because we're not printing it to the terminal. So if we were to run this again, calculating, but then we never returned it. We could then assign it, let's say, maybe to some variable k, and then print k, and then run it, and we will now see 135 again, and that 135 is coming from printing k because we assigned the output of this function call on g to k and then printed k. And finally, just, you don't have to be, we've only been dealing with numbers, but you don't actually have to just be dealing with numbers with functions. They can take in anything. So for example, we could have, I don't know, is chicken, okay? And it's going to take an input string as a variable, and this is getting a little bit ahead, but we can actually check if input string is chicken, return true, let's say, else return false. And what will this do? You hand it in a string, and if that string is the word chicken, capitalization sensitive, return true, else return false. And so let's run that. Okay, and all that other stuff runs again like it did before. And then if we do is chicken, and we do, I don't know, the letter T, we get a false. But if we do is chicken, and we do chicken, we get a true.